Okay, so we're going to do the extension lesson for substitution. This is not a required part of the assignment. It is simply that, an extension to challenge you, or if you want to pick up a couple extra points because there's another one of these that you didn't do so well. Either way. So what we're doing here is, this comes up a lot in mathematics, is it's not always a single number that we're plugging into here. Sometimes we have to plug in another algebraic expression. So for example, instead of plugging in just say 7 for this, we're going to plug in 7m. So, but other than that, the process doesn't change. It's just your answer is not going to be a number. It's going to be another expression. So I have 3 times 7m plus 5. Once I multiply the 3 times the 7, I'll have 21m plus 5, and that's all I can do. So in some regards, they're easier if you know how to do them, because there's less calculating to do. I can't combine the 21m and the 5 because they're not the same thing. This one is 21 m's, this is just 5 1's. An m and a 1, and they're not the same thing, so you can't combine them. Alright, let's look at 2. So we're going to replace the x with negative 10p. I've thrown a negative in here and put a fraction in here. Holy mackerel. Whew! I'm out of control. So let's do 5. We can leave it as 5 halves times, now the negative 10p is going to go on the top. This is really x over 1 when you don't see it like that. So it's really, in fact, you can look at it like this. Times negative 10p. There you go. Put that in the top. Over 2. Minus 7 times negative 10p. Alright. Now, you can do this before or after. Well, let's just do the multiplication here. 5 times negative 10 is negative 50p. Still have the 2 in the bottom. We looked at this in an earlier one. I like looking at it as negative 7 times negative 10. That's going to be a positive 70p. Now, here, 2 goes into 50, because I'm a nice guy. And it does, it goes 25 times. So I have negative 25p plus 70p. Now these I can combine, because they both have a p. So I really have 70 minus 25, right? Positive and negative. So I'm going to say, well, let's just do it. Let's not be silly. 25 is negative plus 70, 45. So I have 45p as my final answer. Alright, so we're just going to try and make them harder. So what we're doing here now is the expression is going to be what we call a binomial. It has 2 terms, and it really is important when we plug it in that we put parentheses around it like this. So for example, negative 7 times x becomes negative 7 times q plus 3. So x is replaced by all of this, and those parentheses are really important here. Minus 15. So when you have this situation, you have to do what we call distribution. We're going to multiply that negative 7 times both of those. So that's going to be negative 7 times q. And when you do a negative 7 times a positive 3, you get a negative 21. So I'll just do that minus 21. And we keep the minus 15. Oops, we got an extra number in there. There we go. Alright, and so I can combine these two. I can't do anything with this q because it's got the q in it. It's not the like term. So negative 7q stays. Negative 21 and negative 15, both are negative, so that's going to be a 36. A negative 36. I think I got that right. 5 and a 1 is 6. Yep. And that's as far as this goes. Alright, last example. I'm going to plug in this everywhere we see an x. Ooh, there's a squaring involved. Holy mackerel, let me sharpen my pencil. Alright, and we got them. Woo! So we're going to do 3 times 2d minus 1 squared plus 5 times 2d minus 1, and see what we get. Now, let's just focus on this for a second, because we were supposed to do exponents first anyway, order of operations, so kind of off to the side here. I'll make a little space over here. I'm just going to deal with what does this look like. So if I do 2d minus 1, squaring means times itself, so 2d minus 1. Multiply it by itself. Now there is a method taught to me by my mother years and years ago to doing this. So it's called FOIL. FOIL? Well, here, let me make it larger. No, we'll do it on this. So here's what we're looking at. 2d minus 1 times 2d minus 1. Okay, and we have this phrase FOIL that we just talked about. All right. Firsts, so I multiply the first term in each of these. This thing times this thing. So that's 2 times 2 is 4. D times D is D squared. All right. O in FOIL stands for outers. These ones on the very outsides. 2D times negative 1, that's negative 2D. Insides, that would be these two. It's negative 1 times 2D, that's also negative 2D. And then the lasts. The last term in each of these is negative 1 times negative 1, which is a positive 1. And by the way, you've made Freddy. He's got eyeballs, and he's got a really big nose and 2 big ears, right? And a smile, if you want to give him a smile. And that's Freddy FOIL. See, it's Freddy. Did I tell you that my mom taught me that? Don't make fun of Freddy. He's my friend. He's one of the only friends I had growing up. So there is some simplification we can do here. I got 4d squared. That's fine. But negative 2d is negative 4d plus 1. So this is what this is. So I write 3 times 4d squared minus 4d plus 1. And then I have this stuff still, plus 5 times 2d minus 1. So now we go ahead and we do that distribution thing. This 3 is going to get multiplied times all 3 things in here. It's going to be 3 times 4d squared, so that's 12d squared. 3 times negative 4d is negative 12d. 3 times 1, of course, just 3. Then over here, I'm also going to distribute. I'm going to take the 5 times both of those. So that's going to be 5 times 2d, so that's positive 10d. And 5 times negative 1, which is negative 5. Now we just have to combine like terms. So we can only combine things that have the exact same variables. So, for example, 12d squared, there isn't another d squared here. So there's nothing I can do with it. It's simplified. But negative 12d, there is another d over here. So they can combine. So if I have negative 12 and positive 10, I should get negative 2 d's. And of course I can combine the two constants. Positive 3, negative 5, it's negative 2. And that is as simplified as it's going to get.